Hi students, let's do one or two questions more, of the magnification title and topic. So this is the question which you can see on the screen. A spherical mirror of focal length 10 centimeter produces a virtual image half the size of the object. Find the nature of mirror and object distance. Now, the first thing here is it says, spherical mirror, okay, focal length is 10 centimeter and it says virtual image. So if it is virtual image, then we know it is an upright, image. Then it says half the size of the object. So that means, the magnification is half. When it says upright means the sign here would be plus. Also, when it is virtual upright diminished, you can say that it is a convex mirror. Okay. Now magnification is equal to plus 1 by 2, and if you see it here, it becomes magnification is equal to minus v by u is equal to plus 1 by 2, and focal distance is, because it's a convex mirror, so it is plus 10 centimeter. Now using this formula 1 by f is equal to 1 by v plus 1 by u, I have just substituted 1 by 10 is equal to minus 2 by u plus 1 by u, and it gives u is equal to minus 10 centimeter. And the distance of image from the pole is equal to minus u by 2, which is, if I just substitute the value, I get plus 10 by 2, which is 5 centimeter. Okay, very good. Okay, let me go ahead and let me do one more question, related to it. Let me move this here. Okay, here it goes. Or let me put it here. This. Okay. A concave mirror of focal length 10 centimeter produces an image which is 4 times the size of the object. So see, it says 4 times the size of the object, right? So 4 times, you can say, you cannot see, it can be plus 4 or minus 4 as well. So basically you can say that mod of magnification is equal to 4. Let's go ahead and read the question. Find the object distance. Okay, so what we will do is, see, remember, whenever we say 4 times the size of object, one of the case can be when it is real and inverted image. Okay, because concave mirror magnifies the object in two scenarios. One scenario is the last scenario wherein we get virtual and upright image, one. And second is when it is real and inverted image. Okay, let's take it case by case. Let's quickly move to case number one. One is virtual and upright image. This is the last, case which we discuss in concave mirror. Okay, in this case we can say m is equal to plus 4 because the image is a, it's virtual upright, you know so we can say minus v by u is equal to plus 4, or v is equal to minus 4 u, or f is equal to minus 10 centimeter. This is given to us. Applying this in the formula, we get, if we just solve it, we get u is equal to minus 7.5. Okay. The other scenario is when we get real in and inverted image. In that case also we get magnified image. So there can be two cases. One is this, other is this. Now in this case again, in this case magnification would be minus 4. Okay. So minus v by u is equal to minus 4, and if we just substitute we get u is equal to 12.5 centimeter. Okay, so there are two cases. This is one of its kind of questions. Usually they do ask. So, just understand it that in this case there will be two cases. Now remember one thing, as I've written it here, if they would have given diminished image, if they would have given diminished image, then it could be only one case, which is the real case, because in concave mirror there can we get magnified virtual upright magnified image in the last case, right? So if they would have given the diminished image, then it should have been only one case real. So this you need to remember. Okay, so my suggestion to you is take your own time. I might be moving fast, but you can always pause your screen and go through it, you know, again. So take your own time, but grasp the concept in a very good fashion. Okay, let me quickly go ahead. Okay, now we will be talking about the combination of mirrors. Okay, here, just trying to adjust. Okay, the combination of mirrors. Now, let's take one mirror. This is a plane mirror, and this is a concave mirror. Okay, now if we have to check, the combination of these, how it would be. So let's put a question to understand this concept better. The question is, find the final image of O. O is object. Let me reiterate the question again. So there is a mirror M2 and there is a concave mirror. This is a plane mirror and this is a concave mirror, which is plane mirror is M2 and concave mirror is M1. Now there is an object which is kept here. Distances are given here. Okay, now find the final image of O of this object after two reflection, assuming first reflection is from M1. So what they are saying is, find the final image of O after two reflection, assuming first reflection is from M1. Okay, so what will happen? Try to understand that whichever is given as wherever the first reflection is happening, what you will do is you will first find the image from that due to that mirror with respect to the object given. Wherever you get the image of this, that would act as a virtual object for the second mirror. Okay, let me reiterate it again. See, okay, yeah, let me adjust it a bit. Okay, see, what they have done here is they have said there are two mirrors. One is a plane mirror and the other is a M1 concave mirror. They have said find the final image of this object which is kept in between after two reflection, assuming first reflection is from this mirror. So what we will do is, keeping this object in place, we will first find the image because of this mirror. Okay, we'll find the image wherever the image is forming due to this object and this mirror. Now wherever the image is, you have to make that as a virtual object for the second mirror and find the image again to get the answer. So first, if I have to summarize it together, I can say first, keeping this object here and keeping this mirror in mind, we will find the image. That image would serve as an object to this mirror, and then we have to find the image, and that would be the answer. Let's get it started. Now for the first reflection from M1, which is the concave mirror. F is equal to minus 20 centimeter, which you know it is always in the case of concave mirror it is minus. And using this formula 1 by F is equal to 1 by U plus 1 by V, we get U is equal to minus 30 centimeter. You know U is minus 30 centimeter. This is given. We can find the value of capital V. Capital V is nothing but distance from pole to image position. Okay, and we get this minus 60 centimeter. Now when we say minus 60 centimeter, remember in first case the incident ray direction is this. So if I talk minus 60 centimeter, so that means the image would be formed 60 centimeter from this mirror in this direction, which would be somewhere here, because this is 30, this is 20, which is 50, and if we add 10 more, this would be 10. So image would be formed here. Okay, now this image would form as a virtual object for this mirror. This distance is 10 centimeter, as we have read for the plane mirror. Whatever is the distance, perpendicular distance from the mirror, it is the same the other side. So this is also 10. So if this is 10, this is also 10. So the final image would be formed here, and this would be the answer. So that is what I have tried to cover. Now I will act as a virtual object for M2. What is I? I is nothing but the image of this object. This object, we will first find I, and then I, this is the I, and this I will be virtual object for this, and the image of that virtual object would be here, and hence this is the required point. Okay, let me go ahead. Okay, okay, now let's try to attempt this question. Now this question says to find the point P image of O after two reflection, assuming first reflection is from M1. So this is the setup which is given to us. Unlike in the last example, this is a concave mirror. This is a concave mirror. This is a convex mirror, and this is a concave mirror. In earlier question, this was a plane mirror and this was a different mirror. But in this case, one is concave and other is convex. Let's name it M1 and M2. They have given the focal distance of M1 as 200 centimeter. Now they are saying to find the point P image of O after two reflections. So basically they want to find the P. They are wanting to find the image which is named as P, and actually that image is of O after two reflection. After two reflections, two reflections, and the first reflection is from M1. Now just note down a few things. Okay, now if you see, let's start with this, because the first they have said hits, the first reflection happens here, and this is a convex mirror. So for the first reflection, remember, because object is O, incident ray is going this way. Now why I am telling you this? Because whichever direction incident ray is going, that will be considered as positive direction. So this is a positive direction. Okay. Now what they have given is f is equal to 20 centimeter. Okay, guys, bear with me. This is not 200. This is 20. So this is a typo. You know, my apologies for this. So f is equal to plus 20 centimeter, because as I said, for convex mirror, the focal distance is always 20 centimeter. Okay. Why? You know, again the same thing, because what we have studied is it is positive. Okay. Why? Because the ray of the light is coming from this direction. Okay. Now u is equal to minus 20 centimeter. Why minus 20? Because see, incident ray is this direction, incident ray is this direction, and just now I explained from here to here, and the direction of u is from pole to object. So pole to object is opposite direction, so it is minus 20. Okay, very good. Okay, why the direction? Oh, I think I missed it out. Why the direction of focus is 20? Because if we complete the sphere, the focus is somewhere inside, and the direction is from pole to focal, to focus. And this direction would be this direction, which is similar to incident ray. Hence, it is plus 20. U is equal to minus 20 centimeter, which I have already explained. Using the formula V is equal to UF, U minus F, we can find the capital V would be 10 centimeter. Now remember, this is plus 10 centimeter. Now, so plus 10 centimeter would be in the same direction as this. So pole to that image point, wherever the image forms, is 10 centimeter. That direction is plus 10. They have said plus 10, and plus would be only from pole to that being in the same direction as incident ray. So that is why V is equal to 10 centimeter. Okay. Now we got this image from this object using the mirror M1, which is convex mirror. Now just forget this for a moment. Now this eye would be a virtual object for this concave mirror. What is the distance of this? This is 30, 20 and 10, which is 60. Now what it will be, whether it be positive or negative. See whether it will be positive or negative. And how do you identify positive or negative? We identify by the incident ray. Now in this case, the incident ray direction, the incident ray 2 is this way. So this way, but the distance from pole to image, which is a virtual object for this mirror, is 30 in this direction. So it will be minus 60 centimeter. Focal length for concave mirror, as you know, it is minus 10 centimeter. Why? Because focal length is, if you complete this sphere, it is somewhere inside pole to image. तो ये हो गया, this would be what? It will be minus. Okay, minus 10 centimeter. Focal is minus 10 centimeter. Using this formula, we can get V is equal to minus 12 centimeter. Now remember, go by the conventions now. Right now we are talking about this mirror only, and positive direction is this way. So negative would be where? Negative would be minus 12, would be from pole to here. So it would be somewhere here. So the final image would be at minus 12 centimeter. Okay. Now to find that is what I've tried to written. Let me quickly read whatever I have written. Remember, for second, image will act as object. I will act as virtual object from M2. Now for second, incident ray 2, this is incident ray 2, will be there. So final image would be right hand side of this mirror, which is this way. So it will be somewhere here, final image. Okay, very good. So just again, pause the screen, go through it, and let's quickly move to the next question. Now, this is a pretty good question, and let me first adjust this so that, okay, here it works best. Okay, the question is, we have two mirrors, one is concave mirror, other is convex mirror. This time they are saying find the coordinate of final image of head of object A. So remember, in the last question it was a point object, but now it this object has some height as well. So what they are saying is find the coordinate of the final image of head of object A. So where is the object A? See, this is the object A. Okay, and AB. So, okay, AB. This is A and this is B. This point is B. After two reflections, they are saying after two reflections, assuming first reflection is from M1. Okay, so let's quickly get started. Now, this point, the incident, let's first, the first reflection is happening here. So let's not talk about it. Let's only talk about this setup. Now in this setup, incident ray would travel like this and then it will get deflected because it is convex mirror. Okay, now F1 is equal to 20 centimeter. Why? Because in convex it is positive always. Let's, and this, okay, let me move a bit at the top. Yeah, F is equal to, so for first reflection of M, if I see the incident ray, so this direction is positive. Okay, F is equal to plus 20 centimeter, U is equal to minus 20 centimeter, because see this direction of U is from pole to U where the object is. So this direction would be what? Opposite to it, opposite to incident ray, hence it is negative, and that is what I've written. Then I have used this formula, V is equal to UF, U minus F. I get V is equal to plus 10 centimeter. Now if I look at this incident ray in this direction, plus 10. So the final image of this setup, first, I'm talking about the first one, will be somewhere here. Now, remember one thing. Right now, we have to, because this has some height as well, so we have to talk something about magnification as well. So, let's quickly move ahead. Magnification we know is equal to Hi by Ho is equal to minus V by U. If I just put in the values, I get Hi is equal to minus 1 mm. Let me quickly go to the diagram. Now that means at this 10 centimeter distance, this, this height of the object would be 1 mm because it is minus, remember minus. So we already spoke about it as per the sign convention that if it is minus, it is below the principal axis, so it will be this. Okay, Right now we have just completed the first reflection. Now we will talk about the second reflection. Now, for the second reflection from M2, F1 is equal to minus 10 centimeter, which is, because it is a concave mirror. Let me quickly go to the circle. This is a concave. So, and now remember one thing, that in this case, the ray of light is coming, the incident ray is in this direction, so this will be positive. Why not this direction? Because this is polished any which ways, so it's coming this way, so this will be positive. Otherwise I can say, see, after hitting this mirror it will go this way, and this is analogous to this, the direction is same, so this direction is positive. In the concave mirror, focal this f is equal to minus 10. Okay, let me quickly again go to the calculation. Yeah, here is the calculation. F is equal to minus 10, u is equal to minus 60 centimeter. Now what is this? Let's quickly move here. Now here, see 10, this is 10, where this will become as a virtual object for M2. So 10, 20 and 30, altogether it is 60, and it is in this direction, pole to this. As I always said, the direction of u and v is from pole to their situation, their location. So pole to this location is 60 distance, and pole to this is opposite to this, so it is negative. Now, so u is equal to minus 60 centimeter, and I just put everything and I get v is equal to minus 12 centimeter. Okay, now magnification also comes into play. What is magnification? Magnification is equal to hi by ho, or I can say it is equal to minus v by u. Now remember one thing, and the most important thing in the entire question is that here HO would be minus 3 mm. See, remember, look at these mirrors. See, this is 1 mm, and now we are talking about this mirror, and this distance is already 2 mm, correct? The earlier, magnification which we found, right? Here we have found out, right? Let me quickly, yes, 2 mm, right? So the total is 2 plus 1, which is 3 mm, and in negative direction, so it is minus 3 mm. So we have to put m is equal to hi by ho minus v by u. Ho is minus 3 mm. Now using this formula, hi by minus 3 mm and minus, what is v? V we know. What is v? V is minus 12. Just put it here. And u minus 60. Just put it here. And we get, we get h1 is equal to 3 by 5 mm above the principal axis M2. So we get, after using this, we get h1 is equal to 3 by 5 mm. So if I go back here, so the final image would be 3 by 4 mm in height from here, because right now we are talking about this mirror, right? And everything is, you know, relative to this. So that is why, when we spoke about this, it was 2 plus 1, because we were talking about this mirror. Okay, and that gives us the final height of the image after second reflection. So it would be above principal axis M2. So that finishes this question. This was the most important question, guys. Just pause your screen and go to it, until you understand it thoroughly. So till then, I'm taking a small break. Thank you very much.